रिकॉर्डिंग चली गई है। Am I audible, everyone?
Yes, sir.
Okay. Good morning, everybody. So basically, today we will talk about, and it was pre-planned, that we will go further about continuity and differentiability. In the last class, we have a lot of discussions on basically the previous two classes with functions, after that limits, some important concepts and some problems on limits. So today we will start, and the limit concept was very brief. Actually, in class 11 we have taught that. So today, especially, is continuity and differentiability. Let us start with continuity. This is a very precise definition of continuity. So the function, actually, whenever you are talking about continuity, limit, always there is a function. That means you are studying the nature of the function in the neighborhood. Calculus is basically you are studying the function in the neighborhood on the real line. You specifically on the real line in that domain or any very small neighborhood. So the function fx is continuous at a point x naught of its domain. If for every positive epsilon, maybe the definition is very difficult to understand, but I will try to make you understand. If for every positive epsilon, we can find a positive number delta. These are very small quantities, very small, negligible, such that modulus of fx minus fx naught less than epsilon for all values of x in the domain of f, for which mod x minus x naught less than delta. This is actually this modulus. Let me explain this modulus. What does it modulus? This modulus means no. This modulus implies this. Mod x less than a means minus a to a. Sorry. Right? So fx lies in the interval this. And if you choose epsilon very small, the strip will shrink thinner and thinner, the region will. So your neighborhood will be more closer. So just like if this is the fx, this is your fx naught, and this is your interval of fx naught minus epsilon, and this is your fx naught plus epsilon. So your fx naught lies in the neighborhood. And if you choose epsilon very small, suppose initially you have chosen epsilon as 0.01, and next you have chosen 0.001, so it will be closer. So that is the concept for every positive epsilon. So you are choosing epsilon. I will show you the graph also. It's positive, always positive. Otherwise, it will be positive. If you choose epsilon negative, this will be positive. So always epsilon is a positive. Clear this interval? Similarly, you see mod x minus x naught less than delta. What does it imply? So I am talking about a neighborhood of x naught. So it's gonna be x naught minus delta, x naught plus delta. So for epsilon, you will get a number delta. So if you choose epsilon, you will get delta. That is why this definition is very, very important for continuity. This is the main definition of continuity. Now I will show you in the graph how this thing geometrically is happening. Can I run this part? Yes, I will show. So I will draw axis, this is x, this is y, and this is the graph function y equal to x. So I will choose first this interval because you have chosen epsilon. So I will choose, the point is suppose P naught. And the P naught point is H naught Y naught. So I want to check the continuity at X naught according to this question. Continuous at a point X naught. So this is the point X naught. So naturally this will be the point X naught. And this will be the point Y naught. Am I clear? If you draw a horizontal line, it will cut the curve, and from there, if you draw the perpendicular, that will be X naught, right? According to the coordinate. Now, what is your Y naught minus epsilon? So I will choose a horizontal strip. This is your horizontal strip. This is your Y naught minus epsilon. This is your Y naught plus epsilon, right? This is your horizontal strip. Okay. Now, this is suppose your vertical strip. For this horizontal strip, you are getting a vertical strip, right? Because for this point, the straight line, just a minute. For this point, the straight line will cut the curve at this point. From there, you are drawing a perpendicular. And this is nothing but your x naught minus delta. For this point, this horizontal line, you are getting a point on the curve, this point. And if you draw the line, this will the x naught plus delta. So for this neighborhood, you are getting a neighborhood. So for choosing epsilon, you are getting a delta. Yes, Isha.
Sir, here if the value of epsilon is taken very small, or the value of epsilon is taken very small too?
Very small.
Okay, the delta may be very small, or delta may be larger than that.
It's like you are magnifying the region, but it's very close. You cannot see in open eye. It cannot be visible in open eye.
Yes, sir, got it.
It's magnified. I have magnified the diagram. So my part is for according to this definition geometrically. You see, if you shrink the horizontal portion, the vertical portion will shrink. That means for every point within this neighborhood, you are getting a point in this neighborhood. So that is the concept of continuity. That is the graph is continuous. That means without lifting the pen, you can draw the graph. That is the one sentence for continuity. No breaking. No break. There is. So what is a discontinuous graph? You cannot get this one. If you take a region, for not every point you are getting a vertical in that portion. But here, for every horizontal line, you are getting a vertical line. That means for every horizontal strip, you are getting a vertical strip. Suppose you change the epsilon. Suppose your epsilon will be next epsilon will be here.
Horizontal strip or vertical strip?
Hey, your horizontal strip, vertical strip. Neighborhood, region. Strip means region. Suppose you have changed the epsilon. More closer, you will get a more closer region. Yes. Both the strips, yeah, this is the thing. That means limit x tends to x naught if x equal to fx naught. This is the condition for continuity. This is the condition for continuity. That means for continuity, this is the definition. Now, what is the criteria for continuity? For continuity, this limit to exist. Number one, existence of limit. Number two, the limiting value must be equal to the function value.
স্যার x এর ব্যাপারটা বুঝতে পারলাম না, x টা কোথায়? x টা কোন? না আমি এই পার্টটা বুঝতে পারলাম না যে fx equals to x naught when x tends to x naught, মানে
Yeah, x is approaching to x naught. X is here.
X a variable.
আচ্ছা স্যার বুঝেছি এবারে।
And fx is approaching here.
Yes sir, got it.
Why is it a vertical strip ki integer multiple over relational?
Real number, all are real. Okay. So main criteria now. This is over.
Like some periodic function होता है तो integer multiple over.
So I will delete this portion. Now, what is the criteria for continuity? Number one, a function is now that is the definition. Definition is given by epsilon delta definition, famous. After this stage, whenever you go to the engineering level or any graduation level, you will study the same definition. People will start from the same definition of continuity. But the question is now, what is the criteria for continuity? This is the criteria. So what is the if and only a function is continuous? If and only limit exists. Number two, limiting value should be equal to the functional value at that point. This is the second condition. If one of them violates, then the function is not continuous. Then the function is not continuous or discontinuous. Okay? So let me start with few diagrams on that. Suppose what are the types of discontinuity? This is number one. Suppose this is x, y, and suppose the graph is like this. This is a point. So this is your functional value, fa. Black dot means the functional value exists. Functional value, that functional value means the height at that point that exists. Function exists at it. And what is the left hand limit? Left hand limit equal to limit extends to a minus fx equal to c your fa equal to l. See from the diagram, this is your left hand limit because you are approaching from the left of a and you will reach here, and that value is equal to the functional value at that point, and that is equal to fa equal to a. But that is not equal to the right hand limit. Am I clear? Am I clear, everyone?
Yes sir, তাহলে এটা কন্টিনিউয়াস না তাই তো?
So the function is discontinuous.
হ্যাঁ স্যার ঠিক আছে।
Okay. Okay, let me draw another diagram. What I meant here?
আচ্ছা স্যার একটা কোশ্চেন, সেটা হচ্ছে তোমার ফাংশনটা কন্টিনিউয়াস কি কন্টিনিউয়াস না সেটা আমি কোন পয়েন্টটা কনসিডার করছি তার উপরেও তো ডিপেন্ড করবে।
Yes.
আমি এখানে এন্ড পয়েন্টটা
Continuity is a property at a point.
হ্যাঁ স্যার
or in an interval.
আমি এখানে এন্ড পয়েন্টটা কনসিডার করছি বলে তার জন্য এটা কন্টিনিউয়াস না তাই তো?
Yes, yes, I'm considering a point. The continuity is a property at a point or in a neighborhood. So I am talking about a continuity at a point. If I am talking about a continuity in an interval, the function has to continue at every point of the interval. That's a good question. Got my point? I am talking about a continuity about a point. Look at here. I have written x tends to a. I have drawn a in the second diagram. That means I am considering the continuity at a point a. I am not taking the interval. If I am talking about an interval, the neighborhood, in that neighborhood the function will be continuous if and only if at each point, each and every point the function has to be continuous. So what about this one? You see the right hand limit equal to the functional value. Right hand limit equal to the functional value at a, that is equal to a, and this is not equal to the left hand. You see, left hand limit is different, right hand limit is different, higher than that. So in this case, your left hand limit not equal to right hand limit, but right hand limit equal to functional value equal to a. This is also discontinuous. This is also discontinuous.
So limit is not exists over a point a.
No, limit doesn't exist.
Limit
This is
doesn't
the criteria. Limit exists means this is the card broken for the previous. Sorry. Okay. It is discontinuous at that. Without lifting the pen, you can draw the diagram. It will be continuous.
Sir, is the left hand limit close to the continuous considered?
Close? What do you mean by close?
That white part.
No. It's a magnified. It's very close.
No, that right hand limit is close and the left hand limit that is open.
This one.
Yes.
This is open though.
If we close it, then it will be continuous, or then also discontinuous.
Acha, next diagram. Is this two diagram clear? Discontinuity. This is diagrammatic. Later on, problem solving. Acha, 1, 2. Next, it can be, as you said, what you can see, the limit exists, but the functional value is not equal to the limiting value. You see, left hand limit equal to right hand limit. So limit exists. That means exists. But that is not equal to the functional value at a. Not equal to the height. Am I clear from the diagram?
Sure, but like the one you did there, like that is cap, but the functional value will it still not be?
No. These two criteria should fulfill. This is the last branch. Okay. Another case. Am I clear, Deepaya?
Yes, sir.
Another thing. These are all finite. Okay. Another. What about the limits? What about the left hand limit? If you approach from the left of x equal to a, fx goes to infinity. And from that, both goes to infinity. So this is infinite. So this is not
So what if it goes up and then meet that point?
yeah. This goes up.
Yes, both the points go up and meet at one point.
Then your limit exists. If you're talking about that point, maybe some continuous portion is there, but this is not happening here. This is intentionally drawn to show you the infinite.
For infinity, the limits of the Janina.
Yeah. So this is another case of discontinuity. I will give you some examples. Too many examples.
Infinity is also
So these are all discontinuous cases. Okay? Clear? Everyone? Okay, let me start with a very simple continuity function. First example, suppose if I talk about mod x. What about mod x? Is it continuous at 0?
yes.
That is the question. Is it continuous at 0?
No, sir.
No, not continuous.
No, sir.
The pion?
No, sir, it won't be continuous at 0.
Not continuous. Okay. What we will check? We will check first the limit. Right?
Acha, sir, wait, sir, just a second. I guess it will be continuous at 0.
Yes.
It will not be differentiable at 0, but it will be continuous at 0.
0. So limit exists at 0. And what is your functional value at 0? 0. Mod 0 will be 0. And you see the diagram, if you know the diagram without lifting the frame, I can draw the diagram. It is continuous. I will show you differentiability later on. Let me go first step by step. Let me clear continuity first. So this is the concept of continuity. Acha. What about box X? Suppose you want to check that X equal to 1. It exists. Okay. What is your left hand limit? What is your left hand limit of box X?
Sir, 1.
X minus 1.
1 minus less than 1. What is the box?
X minus 1 x.
Oh, acha, sorry, box, then it will be 0.
0. Less than 1.
1.
What is your right hand limit?
1.
Sir, it will be 1.
So limit doesn't exist. It's a question of continuity. If a function is continuous, limit exists. But limit existence of limit doesn't ensure continuity. Please take a note of that. Very, very important concept. Continuity implies existence of limit, but converse is not true. A function limit exists maybe for a function, but it may not be continuous.
Continuous limit exists, continuous exists.
Continuous হলে limit exist করবেই, কিন্তু limit exist করলেই ফাংশনটা কন্টিনিউয়াস হবে আমি বলতে পারবো।
Action plot plus error. square plus 1 x square করে লিমিটেড বারবার
হ্যাঁ
x square plus 1 x square এই সূত্র আমরা অ্যাড করছি না
হ্যাঁ।
তাহলে বারবার থাকবে
আসছে সব রকম থাকবে দেখে তুমি কি থাকবে ওই সব এই কন্টিনিউটি অনেক বড় পার্ট সব বলছি শিখে গেলে তুমি নিজেই পারবে আমার আর প্রয়োজন হবে দেখবে তো next I will discuss about different types of discontinuity that is very very important types of discontinuity. So if I talk about types of discontinuity, there are two types actually. First type, second type. First type, second type. First type, removable discontinuity. Under first type, there is a case of removable discontinuity. So, what is the removable discontinuity? Huh? Okay, I'm giving you one example. Fx equal to sin x over x, x not equal to 0, and equal to 2 when x equal to 0. Let's check whether it is continuous or not. Is it continuous function? So you have to check limit first. What is the value of this limit? Standard limit, just type it. So this is 1. So for the function to be continuous, it has to be 1. Because functional value at 0 is 2 given. It has to be 1. So the function is discontinuous here.
স্যার এটা বুঝলাম না
The limiting value of sin x by x is 1.
ইয়েস স্যার
What is the criteria for continuity? Limit x tends to a fx equal to fa.
ইয়েস স্যার
But here what is your f0? 2.
ইয়েস স্যার 2
Instead of 2, if we had written 1, it would be continuous.
ওকে
আমরা যদি 2 এর জায়গায় 1 লিখতাম তাহলে continuous হয়ে যেত।
ইয়েস স্যার গট ইট
So you can remove the discontinuity by redefining the function. That is why the name is removable discontinuity.
ওকে স্যার গট ইট we have to just replace the value of x equals to 0 to 1
Yes. That means the previous diagram I drawn. Functional value is different position and the limit exists. So those type of discontinuity, that is this diagram. Here is the functional value. The limit exists. Discontinuous. This is the example of removable discontinuity. Clear? Removable discontinuity? Huh? Graph is this one. Oh, okay. This is a new graph. You see the limiting value is equal to the functional value. Okay. What is the non-removable discontinuity? This is actually non-removable discontinuity of first kind. In advance, there are some questions about this, identifying the different types of discontinuity. There will be some examples. Match column 1 to column 2, different types of discontinuity. That is a good question.
Oh, it's a borrowed question.
If you don't know, the mains will be there, simple question. Maybe 4 options: removable, first kind, second kind, jump, and all this. You have to identify the discontinuity. If you don't know the theoretical part, you have to reach that question. Okay? So non-removable discontinuity of first kind would be left hand limit not equal to right hand limit. Simply, you cannot remove this discontinuity because left hand limit not equal to right hand limit. How will you remove that? Functional value you can remove. Okay? And suppose, for example, box function. You know the graph for box function. From 0 to 1. So on. Step function. This is discontinuous. What is the jump of this discontinuity? Jump. This is the jump. Sometimes it is called jump discontinuity. You can write the third point.
Sir, 1.
1. Jump discontinuity. So box function has a jump discontinuity of 1. And that is the value of actually what is the left hand limit? Left hand limit will at 1 will be 0, right? At 1. So right hand limit minus left hand limit. That is if x naught plus minus if x naught 0. That is the value of the jump.
X minus x plus 1.
That is the value of the jump. You can calculate the value of the jump.
1.
So you have learned about removable discontinuity, non-removable discontinuity, jump discontinuity. Another kind of function having jump discontinuity. Signum function. Right? I gave you the concept of signum function in the last class. Mod x by x. So its diagram will be like this. This is y equal to 1 line. This is y equal to minus 1 line. This is the jump. Jump will be 2 in this case. Jump discontinuities, you see, what is the left hand limit at 1? Limit x tends to 0, 1. Okay, I am calculating 1. 1 minus box x, it will be 0, right? So that is why the graph is like this. And what is the right hand limit at 1? Sorry, this is 1. More than 1, it will be 1. Look at that, this is 1. So at 1 there is a discontinuity. We know that because box x has discontinuities at the integral points, integer points. 0 plus minus 1 plus minus 2 plus minus 3, these are all points of discontinuity. Look at the graph also. It's discontinuous. So there is a jump, step. That jump is calculated by right hand limit minus left hand limit. And that jump is given by 1. Everywhere. If you go to the 2, If you want to calculate the jump at 2, let us calculate left hand limit at 2. It is what? It is at 2 it will be 1, at it will be 2. 2 plus more than 2 box will be 2. So look at that. What is the jump? Again 1, 2 minus 1.
So fractional part is 1.
Fractional part is not a jump discontinuity. Clear?
Jump is to a y-axis.
Step. It's just like a step. Am I clear, Deepan?
Yes, sir.
This is signal function. Another example. Part of the jump discontinuity. Write the example also. And the diagram. Example diagram. Example diagram.
So non-linear actually now then also jump is discontinuous.
Okay? Now I will go to the second type. Second type is at least one of the limits of is non-existence and infinite. Kali हुई अब second. Then it will be of
Tan x.
doesn't exist. That means
So tan
either limit, yeah. That means you have given a good example, tan x. Limit x tends to pi by 2, tan x. Non-existent means left hand limit and right hand limit not equal.
Sir, exponential function.
Exponential. Okay, tan pi by 2.
a to the power x.
This is tan. This is pi by 2. Because x tends to pi by 2 minus. That means your left hand limit will be goes to infinity, and right hand limit will goes to minus infinity. Also, there are so many functions. In the second type, another discontinuity will be oscillatory. Oscillatory discontinuity. That is sine 1 by x. At 0 it is undefined. Look at that. So there is this oscillation. there will be some oscillation. Let me show you the oscillation. Have you written this part? Yes. What will be the oscillation? It is bounded. Sine function is bounded, but there will be some oscillation. So oscillation will be this is the left portion. If you go more closer to zero, the oscillation will be much higher. So there will be some very concentration of graphs over neighborhood of zero.
স্যার এই ব্যাপারটা বুঝলাম না ঠিক sin 1/x এর গ্রাফটা এরকম কেন হলো ঠিক বুঝলাম না
X tends to zero minus or plus 1/x will be undefined, right?
yes sir
So that is why the graph is oscillating. Plus infinity, minus infinity, plus infinity, minus infinity. Just like oscillation will be much more here concentrated. These are all discontinuous. Oscillatory discontinuity at x equal to 0. Still, sin 1/x is bounded. Please take a note of that very important concept. Zero, at 0 it is discontinuous. At 0 it is discontinuous. Here maybe it is continuous. At other points it will be continuous. But at 0 it is discontinuous. I am talking about 0. Oscillatory discontinuity. This type of discontinuity called oscillatory discontinuity. Still sin 1/x is bounded. Still sin 1/x is bounded. সবই লেখা দরকার নেই নাকি মনে থাকবে
না না একটা আপনি
আরো আসছে
লিখেছিলেন না x/1 ফ্যাক্টরিয়াল ওটা কি ওই মানে আসছে
আসছে
মানে অ্যাঙ্গেলটা বড় হয়ে যাচ্ছে
lot of things are there. I'm just going step by step. Have you written, have you drawn? Define clear?
Yes, sir.
Yes, you see the oscillation is more towards in the neighborhood of origin. Fluctuation is very fast. Yes, reason because if you go near to 0, 1/x will be goes to infinity. Up, high, low, high, low. That is why. Because 0 তে তো discontinuous বুঝছেন You see, if you take any other point, it will be suppose you have taken x equal to 1/pi. What is sin 1/x? 0. See, you are getting a value 0. So 1/pi will be here. It will cut the graph. Suppose you have taken x equal to 2/pi. What is the value? 1. So maybe the value here. You see, all other values you are getting a value, but not at 0. What about x sin 1/x? Very important. Because this limit will discuss. This is a very important example. Why? You see, if you take separately fx equal to x and gx equal to sin 1/x, you are taking two functions,
One is continuous, other is not.
This is continuous. As
Yes,
x
sir.
tends to 0, fx tends to 0. And x0 equal to 0. This is continuous. And just you have seen, this is oscillatory discontinuous.
But bounded.
Bounded. Their product is continuous.
The core product will be continuous.
Product is continuous function because limit is 0 and the function is 0.
হ্যাঁ স্যার, এক্সট্রা জিরো হয়ে গেলে পুরো জিনিসটা জিরো হয়ে যাবে, তখন আর অক্সিলেশন হবে না।
Examples are very, very important. Let me see the graph.
স্যার জিরোতে এসে যেহেতু আনডিফাইন্ড হচ্ছিল, আর এখানে জিরোতে এসে জিরো হয়ে যাবে, সেটা কন্টিনিউয়াস হয়ে যাবে তখন।
Let me see the graph. Y equal to x, y equal to minus x. It's oscillatory continuous. Oscillating at the magnitude decreasing and tends to 0.
Decreasing amplitude.
It's sin 1 by x plus tan sin 1 by x.
No. Tan is a different graph. Especially for sin. Tan is not bounded.
Bounded.
Sin x is bounded. Cos is also you will get the same thing. You can try at home. But this is a very conceptual graph. From graphical point, from mathematical point, from theoretical point. Lot of yes, oscillatory continuous or continuous oscillating function. Continuous oscillating function. So see how interesting is your continuity and differentiability. I haven't talking about differentiability, but I will. So when you are discussing about continuity, it's so interesting the nature of the functions. Right, Different? Understood better?
Yes, sir.
Okay. So if this type of questions in the paper, you nothing have to work out. You just answer with a concept. Nothing you have to do. You just remember the example and the concept behind that and just take it. Another, I will show you last one in this section. X squared. This is also okay. Again, it is continuous. So how? Parabola. Because y equal to x square is a parabola. So nothing have to do in the exams if you have these type of questions. If you want to find the limit, if you want to say something about the continuity, you will easily. Because the graph will be remain in your mind. Just remember the graph and the concept. And maybe the question will be like that. Can we have a function which is continuous, product of two functions which is continuous, but the one of the function is discontinuous, another one is continuous. Yes, we can have. This is the example, and the previous one is the example, counter example. আমরা কি এমন কোন ফাংশন পাবো যার প্রোডাক্ট করলে একটা ডিসকন্টিনিউয়াস ছিল একটা কন্টিনিউয়াস এর প্রোডাক্ট করলে কন্টিনিউয়াস হবে? ইয়েস, অবভিয়াস। এরকম অপশন সাজিয়ে দেবে, মাথার গোল খাইয়ে দেবে। কিন্তু if you have the very clear concept, you will answer, and you will be lucky for getting those questions. Problems will be very easy, just try to understand the concept. Problems to fatafat. In calculus, you will do the problems very easy. And most of the part of JEE mains and advanced is the calculus. 60 to 70%. 60% suppose. At least 60% in any type of engineering examination. And 12 is the most important part. Because 12 itself covers 50%. Yes. So let me write very quick with some notes on continuity. Number one, if fx and gx are two continuous functions, then f plus minus g, that means their addition or subtraction, product, division, provided that gx not equal to 0, are also continuous. Number two,
continuous with
মানে sin 1 by x, sin 1 by x, cos 1 by x,
has
all are discontinuous. What type of discontinuity? Oscillatory discontinuity at zero.
so
But if you write x sin x, x cos x, all are continuous. Continuous oscillating function. If you increase the power, remain same. That's the difference. So this is number one. Number two, if f is continuous and if fx is continuous and gx is discontinuous at x equal to a, then the product phi equal to f into g is not necessarily discontinuous at x equal to a. The example is x sin x, 1 by x. Power, that is also. Yes, x square sin 1 by x. If you want to write power here also, that is also discontinuous. Because at 0 this is undefined, huh?
yes.
That is the main question. You can check the graphs at Desmos. What is the nature and write some graphs in your box. Try to do some experiments on this. Whatever is your queries, that will be answered. You can check in the Google also. Graphs, writing the functions. Next, number 3. Give an example of a function Give an example of a function f and g which are not continuous at a point C belongs to R, but the sum a plus g continuous at C. So you have to give example of a function f and g, both are discontinuous, but their sum will be continuous. So I am giving you one example. Yes. If x is 1 when x is rational and minus 1 when x is irrational. R minus rational number means irrational. From the real number, if you remove the rational numbers, there will be irrational numbers. Because inside rational numbers, integers, fraction, all are there. So if you remove the rational numbers, R will be remaining irrational. That is why when x is rational, it will be 1, and it will be minus 1 when it is irrational. Here, just the opposite. When it is rational, it will be minus 1. When it is irrational, it will be 1. So this is discontinuous. Fx is discontinuous and gx is discontinuous. But their sum, what will they sum? 1 minus 1, 0, minus 1. In all the cases, we will have 0. 0 is a constant function. Any kind of constant function is continuous. This is a very good example. Deepanjan, have you understood?
Yes, sir.
Thanks. What is the column? Any kind of fish. Ask for it. Can I have the upper part? Some properties. These are notes, important notes. Now I will write some properties. Properties of functions. Continuous or linear. closed interval. Theoretically, how much time is taking? Only the theory, because this is the very fundamental part. You don't understand the limit, continuity, and differentiability, it's very difficult to go on to the next chapters. And if it is clear, I guarantee that you will be very good in calculus. Confirmed. Okay. Number one, please take a note. If a function f is continuous, if a function f is continuous on a closed interval, AB, closed interval AB, closed interval AB means A and B included, then it is bounded. Number two, a continuous function whose domain is some closed interval must have its range also in the closed interval. Number three, if f is continuous on closed interval AB, then f inverse is also continuous. So inverse function is also continuous. That means inverse of a continuous function is also continuous. So if the function is continuous, the inverse will be continuous. F inverse. And now the question is, when does the inverse exist? 1 on 2. Bijective. If the function is bijective, then its inverse exists. Right? Number 4. It is sometimes called neighborhood property. Let D is a subset of R. That means some domain is a subset of R, real number. I am talking about a domain which is a subset of real number. And if from D to R, D continuous on D and C belongs to D, if C not equal to 0, then there exists a suitable delta greater than 0 such that for all x belongs to fx keeps the same sign as fc. This is neighborhood of C. That means I'm rubbing the first 2 points. This is suppose C, and this is the domain. This is the domain of the real number. This is the neighborhood of C. C minus delta, C plus delta. That is the meaning of NC delta. NC delta means this neighborhood. I am talking about this neighborhood. C minus delta, C plus delta. So X belongs to this, and this is the function. This is the function. So what is FC not equal to 0? Obviously, what is FC? FC is height. So this is not equal to 0. This is not equal to 0. FC not equal to 0. Then there exists a suitable delta such that for all x when fx keeps the same sign as FC. Yes, you can find a delta. You see your FC is positive. For all x, for any kind of x in this interval, that is also positive. If you take height of any x, those are all positive. This is the property of continuous function. If it would have been a discontinuous, this property will not be there. So if you take the interval, suppose this is your C, and if you take in C minus delta, C plus delta, you see not keeping the same sign. Somewhere it is, maybe it is here also. This branch will be here also. So it's negative, not keeping the same sign. But because of this continuity property, it keeps the same sign in that interval.
So will you explain this once again?
Yeah. Oh, this one. This is the neighborhood property.
Yes, sir.
And what is NC delta? NC delta is this interval. What is FC? FC is the height at C. And if you take any point x in this interval, fx will be positive, height will be positive,
Yes, sir.
and it gives the same sign as FC. That is the sign. If it is negative, all are negative. So this is sometimes called sign preserving property. Sign preserving property of continuous functions. Sign preserving property of continuous functions.
Understood, sir.
Sign preserving property of continuous functions. I'm going to the next point. Next point is number 5, right? Bolzano's theorem. Sometimes this property is called Bolzano's theorem. Very famous. If A and if B are of opposite sign, then there exists at least a point C in the open interval AB such that if c equal to 0, provided if x is continuous in closed interval. So what do you mean by Bolzano? If a and ab, this is the function y dot fx. It's a very important, very important.
Inverted E.
Huh?
Inverted E.
There exist. So you see the graph. This is A point. This is B point. This is the height at A, FA, functional value at A. This is the height at B, FB. FA and FB are opposite sign. You see, FA is negative, FB is positive. So there exists a point C in A and B such that x equal to 0. That means the graph cuts the x-axis at C. And C is sometimes called the root of that equation. C is called the root or 0 of that equation. That's
I did not.
oh. So C is called the root or 0. It is called the root or 0 of that function.
FA is lower than
No problem, that doesn't matter. The sign matters. Whether it is negative or positive. It can be this type also.
So C is basically the point where the line intersects the x-axis.
Yes, at C, C means a point where the height is 0. Height is 0 means C is the root of that function or root of that equation. It cuts the curve at C. At least one point. It can be more than one point also. See? How many points? 3. Alpha, beta, gamma. 3 roots you have. This is a Bolzano. And this is the
So
property
this
of
is also follow the Bolzano rule, right?
yes.
The second graph you draw with 3 intersection points, this will also follow the Bolzano rule, right?
Yes, Bolzano. Sure. And this is the property of continuous function. If it is discontinuous, this doesn't. You can't show this type of things. Because where is the discontinuity? You can't show where is alpha. Okay? Got it? Understood? Bolzanos?
Yes, sir.
Next is intermediate value theorem. If f is continuous on closed interval AB, if A not equal to FB, then if attains every value between if A and FB, at least once in the open interval. If fa not equal to fb, you see fa is not equal to fb, then f attains every value between fa and fb at least once in the open interval. That means a continuous function assumes any value between two values. That means if you draw a horizontal line, you are getting a point. If you draw another horizontal line, you will get a point. If you draw another horizontal line, you will get a point. That is called intermediate value. That means if you have two values, fa and fb, in between, all the values will be assumed by the continuous function. But if it is discontinuous somewhere, will it be possible? Because if you draw a horizontal line, it cannot cut the curve, cannot get the point. Have you understood the intermediate value theory? Let me draw another diagram where you have more than one point. This is your A, FA, and this is your AB. So if you see, if you draw any line, 3 points you have: C1, C2, C3. That is why the term at least once, it can be moved. Okay, that's the intermediate. So these are all important theorems. Somewhere it will cut, somewhere it do not cut. That you don't know, but you cannot apply this one. This is general case. These are all properties of continuous function. If you have a discontinuous function, no question of applying this kind of things. No question of applying Bolzano. No question of applying intermediate value theorem. Nothing. You cannot apply nothing. It cannot be bounded. These are all properties of continuous functions. Okay. Okay. I will now move to. These are all continued. Huh? No. I will just give you a concept of differentiability. Yeah. I will use differentiability. Differentiability. 15 minutes time. What is the first principle of derivatives? First principle of derivatives. Dy dx. Do you know what is dy dx? First principle of derivative. Limit h tends to 0. F of x plus h minus fx over h. You can get actually derivative means limiting of this rate of change of y with respect to x, or rate of change of the function with respect to x. Velocity, rate of change of displacement with respect to time. Acceleration, rate of change of velocity with respect to time. So these are all rates. You can calculate, you can apply derivative everywhere. So what is the physical and geometrical significance of the derivative? Geometrically, suppose this is the point xy and this is the neighboring point x plus delta x, y plus delta y. Very neighboring. This is the tangent. So actually derivative is nothing but the slope of the tangent. So dy dx represent the slope of the tangent. By using this geometry, we can show that. So geometrically it represents the slope of the tangent. Dy dx. Now sometimes if you want to test the derivative, you can apply instead of this formula. If dash t equal to limit x tends to a fx minus fa over x minus a. You can note down this one. We will apply in problems. So if you are talking about derivative, testing of derivative, whether the derivative exists or not, that means you have to test this limit. And if you are talking about limit, it will give you left hand limit and right hand limit. Evaluating left hand limit and right hand limit, they must be equal. They must be equal. Otherwise, the function is not differentiable. Otherwise, the function is not differentiable. So, this type of function. For differentiability means you are drawing a tangent at that point. What about mod x? Let us check. Let us check. For example, I am checking for mod x. When starting with a very simple function. Is it continuous? We have checked. We have started with this. This is continuous. Now I am going to check whether it is differentiable or not. Let's check. So I will check the differentiability at x equal to 0. That limit. So left hand derivative at 0. So that is equal to limit x tends to 0 minus fx minus f0 over x minus 0. Applying that formula, that is from this is another form of this first principle actually. This is another form of this form. If you write h equal to x minus a, you will get this form. And if you write x minus a equal to h, you will get this form. This is another form of first principle. So I apply this. Right. What is mod x minus x? Minus 1. What is right hand derivative? Does the limit exist? No. Left hand derivative is different from right hand derivative. This limit doesn't exist. So left hand derivative at 0 not equal to right hand derivative at 0. Hence, the function mod x is continuous but not differentiable. Let me check the diagram. This is at 0. You see at 0 there is a sharp peak or corner point. So if there is a sharp peak or corner point or peak, you cannot draw tangent at those points. That is why the function is not differentiable at 0, but it is continuous. So continuity doesn't ensure the differentiability, but differentiability ensures continuity. Yes. So let me write a very important concept you must note down. Differentiability implies continuity, implies existence of limit. But the converse is not true. Differentiability, define, please note down also.
Yes, sir, noted.
Differentiability implies continuity, implies existence of limit. But the converse is not true. But the converse is not true. Example, yeah, this is the example. Mod x, which is continuous but not differentiable. So also take a note that in the graph, if you know the graph of that function, how will you identify from the graph that function is continuous, function is differentiable? From the graph also, if there is a sharp point or corner point, the function is not differentiable. Sharp point or corner point, the function is not differentiable. That is geometrically. Geometrically, if there is a sharp point or corner point, the function is not differentiable. You have to leave after 5 minutes. Okay. Then you leave after 5 minutes. No? Okay. Define, can you see the board? Another example.
Sir, you got disconnected for the last 1 minute.
Yes.
In
But
last
I
1
haven't done
minute.
anything. I haven't done anything.
Okay. Okay, sir.
Now I will do another example. If x equal to the most important function we had talked about. Yeah, this one. Check whether it is continuous. First thing, is it continuous? Yes, it is continuous.
Sir, can you read what you have written? The screen is very much hazy.
Very much hazy.
Can you read what you have written? The screen is not.
I think with the camera, the problem with the camera. Can you see
No,
now?
sir, there's a problem with the internet. So the screen is very much hazy, so I can't see it properly.
I think the network problem maybe.
Yes, sir.
Okay, this is continuous because what about the differentiability? You have to check the differentiability. Is it differentiable at 0? Test. How will you test? Okay. I have a testing formula for differentiability. What is the formula? This is a beautiful formula. Any kind of function you can change.
So we won't be using this one.
Yeah, this one I am using. Fx minus fa by x minus a. Here a is 0, 0. Clear? Because f0 is 0. So what do you have now? Doesn't exist. Not differentiable. It is not differentiable. The function is continuous like mod x, but not differentiable. Let's see. Very good example, very good and important example. लिखे आओ. Continuous, but not differentiable. So continuity doesn't ensure differentiability, but differentiability ensures continuity. Continuity ensures existence of limits.
Sir, what's one way to
What we go? Semi oscillation. Cos sign is same, similar. Decimal से देखें नहीं और भी short. Another example, x square sin 1 by x. Check, please. I'm dropping this part. X square sin 1 by x. Is it continuous? Yes. What about the differential? What about the differentiability?
Sir,
Hmm.
exist.
Is it differentiable? Question is very specific. Differentiable or differentiable? Not differentiable. সেটা চেক করতে বলেছি.
X into sin 1 by x.
After this question, you can, after solving this, giving your opinion, answer. What is the limit? This limit. What is this limit? So again, applying this formula, this is continuous. No question about that. This is continuous function. Fine. What about the differentiability? F dash 0, you are applying limit x tends to 0. Fx minus f0 by x minus 0. Limit x tends to 0. X square sin 1 by x minus 0 by x minus 0. That's gonna be what about this limit? 0. So differentiable, you are getting a limit of this differentiation. So this is differentiable actually. But x times 1 by x was not differentiable. So this is differentiable and continuous. This is differentiable actually. That means you can do derivative. Let us do the differentiation directly. X square sine 1 by x will be cos 1 by x, and by chain rule you are getting minus 1 by x square plus 2x sine 1 by x. So that's gonna be minus cos 1 by x plus 2x sine 1 by x. X not equal to 0. I will take 5 minutes more. Okay. Just few examples. So the question of non-differentiability. If there is a corner point, if there is a corner point, this is the point of non-differentiability. A corner. You are talking about these things previously. I told you, just wait. Maybe it is discontinuous. It is discontinuous. Then it is not differentiable. If you have vertical tangents, vertical tangent at this point, vertical tangent intersect the curve, not differentiable. Okay, so these are all non-differentiable points. Now, examples of functions which are everywhere continuous. Follow. Everywhere continuous functions. Examples. Polynomials. Everywhere continuous and differentiable. Smooth functions. Smooth functions. And sin x cos x. Exponential. Any kind of exponential. Logarithmic in its domain. Question. The number of points at which the function fx equal to 1 by log mod x is discontinuous is options 1, 2, 3, 4. Tell me. Deepan, tell me.
1 minute, sir.
Number of points. You have to just mention the points.
Sir, 3.
It's
Sir, yes, option C.
yes, correct. Because
So 0, 1, and minus 1.
x equal to 0, it is undefined. Log 0 is undefined. So 0 is a point of discontinuity, and the function will be fx will be undefined if and only if log mod x not equal to 0. That means mod x not equal to 1. That means x not equal to plus minus 1. So you have 3 points, 0 plus minus 1. So you have 3 points of discontinuities. C, option C. Here, number 2. In order that the function if x equal to x plus 1 whole to the power cot x is continuous at x equal to 0, if 0 must be defined as zero e 1 by e none.
Sir,
Yes.
sir, can you read the question once? It's not
Yes.
visible properly.
In order that the function fx equal to, oh, this is red pen, that is why you can't visible, right?
Yes, sir.
Okay, I will write with a blank, sorry. In order that the function fx equal to x plus 1 whole to the power cot x plus 1 whole to the power cot x is continuous at x equal to 0. Is continuous at x equal to 0. F0 must be defined as, what should be the value of F0 to be the function to be continuous? What is cos 0? Right? Infinity. So this is 1 to the power infinity form.
Sir, option B, E,
Option
option 2,
option
2, like
A.
option number 2. Option number 2, like the answer will be E, Euler's number.
E. Right. Am I clear? One to the power infinity form. So this is E. And x by 10x is 1. So f0 should be E to the function to be continuous. F0 should be E to the function to be continuous. Okay? Okay. Up to this. So today we have covered the theoretical part of continuity and differentiability. All theory, rigorous theoretical part, and less problems. But in the next class, we will solve problems and maybe some graphical knowledge in the problems, analytical, rigorous solving of JEE Mains advanced problems on continuity and differentiability in the next class. Okay? Thank you.
Okay, sir. Thank you, sir.